Ketchup seems like one of the simplest foods on the planet. A smooth red sauce squeezed from a plastic bottle onto fries, burgers, or hot dogs. But behind every bottle lies a massive industrial operation built around high-capacity cook kettles, deaeration systems, precision blending tanks, steam-heated pipelines, stainless steel mixers, and filling lines that bottle thousands of units per minute. What starts as humble tomatoes, vinegar, salt, sugar, and spices becomes a shelf-stable, perfectly consistent product through carefully engineered processes designed for taste, safety, and long-term stability. And today on the How Factory, we're stepping inside the huge factories where ketchup is sorted, washed, cooked, evaporated, sweetened, seasoned, homogenized, pasteurized, bottled, capped, labeled, and shipped worldwide at astonishing speed. What looks like a simple condiment is the result of advanced food engineering and high-speed mechanical automation. The process begins at the ingredient intake area, where truckloads of tomatoes, fresh, diced, or as concentrated tomato paste, arrive at the factory. Many modern ketchup plants rely on tomato paste because it's more efficient to ship concentrated solids than fresh fruit. These pastes come in massive drums or tanker trucks and contain the natural essence of ripe tomatoes condensed down into a thick, deep red base. Before anything else happens, the paste must be inspected and tested. Lab technicians evaluate color intensity, pH levels, natural sugar content, microbial counts, and seed or skin residue. Only paste that meets the ketchup recipe's strict specifications is approved. For plants that use fresh tomatoes, the fruit travels through sorting lines where high-speed cameras and air jets remove any tomatoes that are underripe, overripe, bruised, or mold damaged. The remaining tomatoes pass through high-pressure washer tunnels that blast them clean, before automated peeling and pulping systems reduce them into a thick, smooth slurry. Whether starting from fresh pulp or industrial paste, the tomato base then moves to massive blending tanks. These tanks are made of food-grade stainless steel and can hold thousands of liters at once. Industrial pumps transfer tomato paste into these tanks, where powerful agitators churn the mixture continuously. At this point, additional water is added depending on the final ketchup formula. The mixture is brought to a specific consistency so that sugar, vinegar, salt, and spices can dissolve evenly. Steam jackets surrounding the tanks begin heating the mixture, gradually raising its temperature. The heat not only thins the tomato base, but also prepares it for one of ketchup's most important steps: cooking and evaporation. Once warmed, the mixture is pumped into huge steam-heated cooking kettles, cylindrical vessels that function like high-capacity pressure cookers. Inside these kettles, steam coils or jacketed walls heat the tomato base to the precise temperature needed to develop ketchup's thick, glossy texture. Agitators keep the sauce moving so it doesn't scorch. The cooking stage evaporates excess water, concentrating the tomato solids. Factories monitor something called Brix, a measurement of soluble solids that indicates how thick and sweet the ketchup will be. As the mixture concentrates, steam vents release evaporated moisture. Some facilities use vacuum evaporators to reduce moisture at lower temperatures, preserving flavor and aroma. This is where the seasoning begins. Sugar and vinegar, two of ketchup's defining components, are added in carefully measured quantities. Industrial sugar silos feed sugar through screw conveyors, dissolving it smoothly into the hot mixture. Vinegar arrives in tanker trucks and is injected through sanitary pumps, instantly dispersing throughout the sauce. Salt enters through metering systems that prevent clumping. Seasoning blends containing onion powder, garlic powder, paprika, and various proprietary spices are added next. Many major brands guard their exact formulations closely. High-shear mixers ensure that dry spices break down fully and integrate into the mixture without forming lumps. Once all ingredients are added, the mixture thickens further. Additional cooking time develops the deep red color and the balanced, sweet, tangy flavor consumers expect. Technicians sample the sauce regularly, testing viscosity, acidity, sweetness, color, and aroma. Industrial ketchup must be extremely consistent from batch to batch. Any variation in pH or thickness could affect shelf stability, squirting behavior, or consumer perception. Inline sensors measure Brix, flow characteristics, and temperature in real time. If the mixture is even slightly out of spec, adjustments are made immediately. But ketchup still isn't ready to be bottled. At this stage, it must undergo homogenization, a high-pressure process that breaks down pulp particles into tiny, uniform sizes, giving ketchup its silky, pourable texture. The sauce is pumped into homogenizers where it is forced through narrow valves at pressures up to hundreds of bar. This intense pressure shreds particles and emulsifies the sauce. Without homogenization, ketchup would separate in the bottle into watery and chunky layers. After homogenization, ketchup becomes smooth and stable. The next step is deaeration. Even with cooking and mixing, small amounts of air remain trapped in the sauce. If left inside, this air could cause oxidation, discoloration, or off flavors during storage. Deaeration tanks use vacuum suction to pull microscopic air bubbles out of the hot mixture. The ketchup enters spinning chambers or vacuum domes that remove dissolved gases. The result is a dense, uniform sauce that resists color fading and maintains long-term quality. After deaeration, the ketchup moves toward pasteurization, a vital food safety step. Though the cooking stage kills most microorganisms, pasteurization ensures complete microbial stability. Ketchup passes through heat exchangers that rapidly raise its temperature to the pasteurization threshold. Plate heat exchangers, tubular heat exchangers, or scrape surface systems heat the sauce quickly and evenly. Hot fill systems immediately transfer the pasteurized ketchup into sterile piping that leads directly to the filling line. This closed-loop system prevents exposure to outside air or contaminants. The ketchup remains hot, often around 85 to 95 degrees Celsius. As it approaches the bottling carousel, while ketchup is being mixed and cooked, another part of the factory prepares the bottles. Most ketchup plants make their own squeeze bottles from PET or polyethylene preforms. Blow molding machines heat the preforms and inflate them into full-size bottles using compressed air inside metal molds. The freshly molded bottles are still warm and extremely clean, so they move directly through air conveyors into the filling hall without risk of contamination. Glass bottles, if used, arrive from external suppliers and are washed, dried, and sterilized before entering the filler. Inside the filling hall, a highly controlled, sanitized environment, the bottles pass through sterilizing tunnels or air blast stations. Then they enter the filling carousel. This machine rotates continuously with dozens of stainless steel filling heads that dispense ketchup with astonishing precision. Because ketchup is thick and viscous, filling heads use piston pumps, gravity valves, or volumetric dosers calibrated to fractions of a milliliter. As each bottle rotates under the filler, hot ketchup is injected through nozzles that retract at the perfect moment to avoid drips. High-speed lines can fill hundreds of bottles per minute. Immediately after filling, the bottles move to the capping station. Caps or lids arrive through vibratory feeders that orient them into position. For plastic bottles, screw caps with tamper-evident rings are tightened with exact torque. For glass bottles, metal caps or twist lids are heat-sealed to create vacuum seals. Hot-filled ketchup creates a natural vacuum as it cools inside the bottle, helping form a tight seal. Sensors check for cap presence, torque accuracy, and airtightness. Any defective bottle is automatically rejected. Next comes labeling. High-speed labeling machines wrap or apply adhesive labels onto each bottle with laser accuracy. Labels must adhere perfectly even to warm bottles, so adhesive formulations and applicator pressure are carefully controlled. The labeler applies brand graphics, nutritional information, batch codes, and traceability data. Vision systems verify label alignment, print quality, and barcode readability. After labeling, bottles pass through date coding machines that ink or laser mark expiration dates and batch numbers. From here, finished bottles travel to case packing. Automated packers group bottles into cardboard cartons or shrink-wrapped trays. Case erectors fold cartons at high speed, glue them, and slide bottles into place. Shrink tunnels heat-wrap plastic film around trays, securing the bottles for shipping. Once packed, cases move to palletizing robots. Large robotic arms that lift entire sets of cases at once and stack them into perfectly aligned pallets. Stretch wrap machines then bind each pallet tightly to prevent shifting during transport. Behind the scenes, quality control teams run constant tests. Every batch of ketchup is checked for pH, viscosity, color intensity, bricks, microbial safety, and flavor consistency. Samples undergo shelf life simulations in temperature-controlled chambers. Food scientists evaluate texture and taste using trained sensory panels. CIP, clean in place, systems run between batches, flushing kettles, pipes, fillers, and heat exchangers with hot water. Alkaline cleaners, acids, and sanitizers to prevent bacterial contamination and allergen crossover. Everything from ingredient dosing to bottle torque is logged digitally for complete traceability. Once pallets are complete, forklifts load them into trucks or onto shipping containers. Cold storage isn't required for ketchup, but temperature-controlled warehouses protect product quality. Distribution centers move the product through automated inventory systems until it reaches supermarket shelves worldwide. By the time a customer squeezes ketchup onto fries or burgers, that bottle has passed through dozens of mechanical, thermal, chemical, and quality control checkpoints, all ensuring flavor consistency, safety, and long shelf life. What makes ketchup production so remarkable is the blend of traditional cooking and cutting-edge automation. The basic ingredients, tomatoes, vinegar, sugar, spices, are ancient, but today's production relies on precision steam heating, homogenization science, vacuum deaeration, automated filling, and robotic packaging. Every bottle is the result of chemistry, engineering, and perfectly synchronized machinery working at industrial scale. And that is exactly how ketchup is sorted, washed, cooked, blended, homogenized, pasteurized, bottled, capped, labeled, packed, and shipped worldwide. An impressive combination of food science, thermal engineering, and high-speed automation hidden behind a simple everyday product. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines and systems behind everyday products.